So this is the classwork review for the ambiguous case classwork, questions 1, 3, 5, and 7. So we're going to try to figure out how many different triangles, non-common triangles, can be formed with the given information. And so again, it's again law of sines. So here we see we're going to be using A and B. So here the sine of A over A equals the sine of B over B. And so now we have in this case the sine of A is the sine of 30 over A, which is 4, equals the sine of B over 6. We're going to multiply both sides by 6 to be able to get sine of B by itself. And so here we're going to type in a 6 sine of 30 over 4. So we're a calculator, and we're going to type in 6 sine of 30 over 4. So divide by 4, and we're going to get in this case a value of 0.75. All right, so we see in this case sine of B equals 0.75. Now we're going to type in a calculator. We're going to find in this case sine negative 1, or the inverse sine of 0.75, to get an angle measure. And so we go back to our calculator here, and we type in here, we're going to do second sine here, right? Sine negative 1. And we're going to type in this case 0.75, because that's what we had here. And so we're going to get an angle measure of 48.59. So we're going to round this off, okay? So it's not to the nearest tenth. Right now, they're not asking us in this case, rounding off to the nearest tenth or hundredth or anything. We just go round to the nearest degree. And the reason is we want to figure out how many different triangles we can form. So here, they don't tell us we'll round to the nearest degree, and that'll be 49 degrees in this case, so 49 degrees. So we can get 49 degrees. All right, and so now we're going to set up the following. Our table we talked about before, A, B, and C. And in this situation, A represents our given, B represents our solved angle, okay, and here our C is going to be our leftover. Sorry about the bad handwriting, still waiting for that stylus. Okay, so we're going to make a table here, and the A value is going to be given, is not going to change, because there's two possible situations. First off, it could be A is 30 degrees. We know A is 30 degrees, and B will be 49 degrees. So what's left over for us would be, in this case, C would be 180 minus 30 minus 49, or 180 minus 79, 101 degrees. That's a possible situation. Here, we also look in this case of 30 degrees, and the supplement of 149, so 180 minus 49. And 180 minus 49, I believe it should be 131 degrees. And so, it's 49. And so that would mean in this case, the leftover angle C would have to be 180 minus 30 minus 131, or 180 minus 161. So 180 minus 161, I believe, is 19 degrees. Here we have two possible triangles that can be formed. Notice in this case that we have enough agreement. Well, it definitely worked out for the first one, but we also see in this case it works out for the second one as well too. Enough degree measure for the supplement to work out for our third angle here. Notice that we don't change anything. We don't take the supplement of the given stays the same, okay? So that's our plan for all these questions here. Make a table, and so we'll say two possible triangles. Okay, now for question number 3. Number 3 is the same type of question, so we're going to go, in this case, the sine of A over A equals the sine of B over B, which is, again, the sine of 150 degrees over 4 is equal to the sine of B over 6. And so now we're going to multiply both sides by 6 again. So the sine of B is equal to 6 sine of 150 degrees over 4. And again, we'll plug into our calculator. And so 6 sine of 150, 6 sine of 150 divided by 4. wait a minute, that's same thing, 0.75. That's so crazy. Until we remember in this case, the sine of 30 and the sine of 150 should have the same exact value. So we are going to get sine of b is equal to 0.75, and sine negative 1 of b, or 0.75 actually, I believe we said about 49 degrees. Now let's make our table again. A, B, and C, where our given is going to be A, but this time it's 150. Okay, that's the angle measure we're given. B is 49 degrees. And C, well, if the total number of degrees in this case of the triangle is 180, we would have negative 9 degrees, which we know that's not possible. Honestly, there's no possible way to be able to get a triangle in this case. There's not enough degree measures. We have this and this. Here we have a situation where there's no possible triangles. Now you say, what the supplement? Well, if I did 150, and the supplement of 149 we said was 131 degrees, even more so, not possible. So we can have situations where we do everything right and we don't get any measurements. So let's go on to our question number 5, where A is 15, B is 12, and the sine of B here, angle B, is 45. So we'll set this up again. So the sine of A over A equals the sine of B over B. And so now we have the sine of A equals 15 over 7 over 15 equals the sine of 45 over 12. And we're going to multiply both sides by 15 to get the sine of A by itself. So we have sine of A is equal to 15 sine of 45 over 12. Okay, so 15 sine of 45 over 12. Let's get our calculator out. 15 sine of 45 divided by 12. And we enter, and we get 0.883880. Okay, so we get this value, all right? And so here, we're going to do the following. Instead of typing out the whole thing, we're going to do sine negative 1, second sine. And now, if we want to put whatever answer we got previously, we're going to go to a calculator and do second negative 1. Second negative 1 means in this case it'll enter in the last answer that was completed, and here it was the 0.8838834765. And now enter, and we get in this case 62.114443 443316. We're going to round off to 62 degrees. Okay, so in this case, so we had sine negative 1 of 15 sine of 45 over 12, which you can actually totally type in here in this case. You could totally type it in. Make sure you close parenthesis here. And you would still get, I think we said 62 degrees. Let me double check to make sure. 62 degrees? Yeah, 62 degrees. Okay, so the measure of angle A equals 62 degrees. So again, we have our given, solved, and left over. I'll just put the left LO. Okay, so given, solved, left over. Our given value angle measure was 45 degrees. Here, in this situation, our angle measure was B. We solved for angle A, and we're left over is C. Okay, so our given angle we know is 45. Our solved angle is 62 degrees, and the leftover angle is going to be, well, 45 plus 62 is going to be 107. So 180 minus 107, that would be 180 minus 107, 73 degrees, I believe. Okay? All right, now let us consider now the supplement. Now the given angle, angle B, still is 45 degrees. And so now we do 180 minus 62, which is going to be 118 degrees. Okay, so we see how much 18 degrees would be working out fine as well. That's the supplement in this case of the solved angle. And now 45 plus 118, and that's going to be 163. So 180 minus 163, I believe, should be 17 degrees. So now we see in this case, yes, there's a possible triangle for the first one and a second different triangle for using the supplement of the angle solved. Okay, again, we go back to the idea that the sine of a sine of acute angle is equal to the supplement, the sine of the supplement of the angle. Okay, and finally, in this case, we have number 7. So number 7 is the following. So let's make sure I get that here. Okay, so all right, so we have A is 5, B is 8, and measure angle A is 40. So we have in this case, sorry about that, straight mark. So we're going to do the sine of A over A equals the sine of B over B. And so here, sine of 40 degrees over 5 equals the sine of B over 8. And again, we're going to multiply both sides by 8 to get the sine of B by itself. And so sine of B is equal to 8 sine of 40 over 5, which means the measure of angle B equals the inverse sine of 8 sine of 40 over 5. And so just to show you that it works out, let's type into a calculator. Okay, here we go. We're going to type in second sine. Oops, second sine. Sorry about that. I'm going to do this, clear this here, delete that. Second sine. And here we're going to type in 8 sine of 40. I'm going to close that parenthesis there and then divide by 5. So you can type the whole thing in here. You don't even need to find the numerical value of the decimal value. You just type in whatever you got because sine of 40 is a real number. And we find out that we get, oh, error domain. Wow, what's going on with that? Well, let's see. Let's go to, let's see. Well, did I type something wrong? Well, let's see. All right, let's go and continue on. Let's take a look and see what happens when we get, oops. Let's see what happens when we get, in this case, just 8 sine of 40 over 5. Oh, wait, error syntax. Oh, sorry about that. Oh, I see. That was that decimal place here, so we need to delete that part. Shucks. So enter. Well, we got 1.028468. All right, so let's see now. Now let's try second sine of the answer. Error domain again. Well, what does that mean? Okay, so let's go back to this whole idea. All right, if in this situation, in this case, if the inside number here, okay, if 8 sine of 40 over 5 is greater than 1, then there is no solution because your domain for, in this case, what you're only allowed to work out in this case, is that the angle measure that you can only find has between, in this case, value between 0 and 1. It cannot be greater than 1. Now, why is this, again? Well, here, the sine ratio is like opposite over hypotenuse. Normally, that's how it is. So we know the hypotenuse is the longest side of the triangle. So you can't have the leg opposite, a leg being longer than the opposite side opposite, though. So here, there's no solution, which means no possible triangles. All right, ladies and gentlemen, hope this has been helpful. And if you have questions, please leave them in the comment section below. And if you found this helpful, please hit the like button and subscribe so that you can be updated for any new videos. Thank you so much, and I will see you guys in the next video.